Hey, folks. Well, welcome to this session about from cloud native to agentic applications. So I will try to cover quite a lot of things. So I will try to go fast. I have only 24 minutes now, so I will just go fast, full on. My name is Mauricio Salatino. I work for a company that's called Dash0. This is a sponsor session, so I will show a little bit of the product. I am not used to do sponsor sessions, but I'm here, so I'm super happy to be in this conference. So let's get started, right? So I assume that we are all Kubernetes people. We all know how to run microservices. With agents, there are a bunch of new things coming up, right? And I've seen a lot of presentations, even today, talking about these topics. So this is kind of like, it's interesting in one side. In the other side, we need to recognize that this is in flux, right? Like it's changing every day. We need to prepare for a bunch of different things. And if today we see 10,000 projects, well, 5 of them, we're actually the ones that we will need to learn. So I wanted to kind of like share some ideas for platform engineers, but focused on what developers are doing on the agentic space. So this is not the typical, platform engineering presentation about agents, but there are a lot of topics that connect to that story and that narrative that we already know. So when I think about like the agentic space, I think in 2 big blocks. One is the infra side of things, where we talk about like GPUs and how we run LLMs, on premises or at scale. The other one is AI gateways. Mario today did a great presentation about LLM, gateways and AI gateways. And then KV caches to optimize, like the information that is being exchanged with LLMs and our applications and all that stuff. On the other side, we see, as I mentioned before, agentic frameworks. There are probably 10,000 of those, and they are just being created every day. And then we see new protocols that also in Mario's presentation was very, very interesting. If you can see the recording for that presentation, he went a little bit more in detail about MCP and A2A, and other things like skills that are things that as platform engineers we will need to manage at some point, right? If we want to do this at scale with like large development teams, we will need to do some stuff there. On the infra side, the funny thing is like this conference, I saw a lot of like GPU and scheduling presentations that are great. But I do feel that we are very well prepared for that space, right? So if you want to go into infrastructure in the AI space, you will see that like all the major LLM providers are hiring Kubernetes people, right? Like if you look into this is like Anthropic hiring in San Francisco, but also in London, around Europe. And you can see this like exposure to Kubernetes, infrastructure as code, container orchestration. That's kind of like our stuff. So you will need to spend some time learning about like machine learning, pipelines, and probably GPUs and scheduling and all that stuff. But all the basics we have. So we need to spend a little bit of time of that. Same with OpenAI, hiring New York, Seattle, London, and all over the place. Kubernetes, scheduling, observability, reliability engineering, high performance computing, and GPUs you will need to learn. We will need to spend some time there. Luckily enough, like you're in the right place. Like there were tons of presentations about that, tons of smart people that you can connect and start contributing to projects, which is the way to go. And then finally in Singapore, like ByteDance is a little bit more direct, right? Build and scale Kubernetes clusters that includes design and manage ultra large scale Kubernetes clusters, right? Like that's pretty much kind of like this community. So I think that like from that side, we are kind of safe. But when you look into the developer side of things, a lot of crazy things are happening, and we need to prepare in our way our platforms to support these development teams. So what do we need to know about agents as platform engineers, right? That's the point of the presentation. And I will show some examples, and then we can go into different tangents depending on how are we feeling today. I do not have much time, so I will speed up. So from an architectural point of view, right? Like when you're building monoliths, microservices, or even event-driven applications, we kind of know how the system scales, right? Like if it's like a publisher-consumer, you scale like the brokers and the replicas and the consumer groups and all these things. If you are talking about microservices, more traditional microservices, you create more replicas. So it's kind of, we understand that space. The agent-based architectures are mutating every day, and they are changing. So we cannot say that there is a single agentic architecture nowadays. So we need to prepare for different flavors and different styles, depending on the tools that our engineering teams are picking up. And a bit of a disclaimer, right? Because this is a little bit different, right? So in this presentation, I decided to focus a little bit more on business agents and not on coding agents. But the line between these 2 things, it's kind of like being blurred a little bit. I see a lot of people using coding agents for building business agents, and the other way around, which is kind of like complicated. But business agents are a little bit more critical in the sense that they are exposed to our customers, and they are executing business operations that are way much more sensitive than generating code that is going to end up in a pull request that nobody will review, right? So it's a different kind of like a scenario. Think about agents that are exposed to customers that are dealing with business operations. For that, as I mentioned before, we have tons of different agentic frameworks. I will not describe any in particular, but they allow you to create agents that are basically prompts with connection to tools, and that's where the Model Context Protocol pops up. How many people knows about MCP? I will not talk about this because most of people is like aware of what this is. Just connecting LLMs with APIs and tools, but just the new protocol. The one thing that I wanted to mention there is that this was introduced in November 2024, so it's recently kind of new. And it was created as a way to connect LLMs to APIs from a very, let's say, a hacky way, where you just you want to make that connection happen, and you create a protocol for it with the basic functionality, and then you make it mature. Now it's part of a new foundation, the Agentic AI Foundation, which is good because in a way, if we want to rely on this protocol, it's going to be maintained and matured by different companies. Of course, if you go to Reddit, you will see MCP is dead, long live the CLI, which is a different approach to connect LLMs to actual services. But I do believe that MCP has a space for agentic applications in large organizations. We kind of need that abstraction, and we need gateways, and we need things to connect our LLMs to our applications. Now I'm an ambassador for this foundation, so I cannot use this slide anymore. This is the last time that I'm going to show that. But it's a good point, right? The other hand, you have protocols that are designed to communicate agents, like the A2A protocol. Again, if you know about this, it's cool. If you haven't used it, I recommend you to check it out. This was introduced in April 2025, so this is a year ago, a little bit more than a year ago, right? This is for agents to talk to each other. So think about two LLMs that needs to collaborate in solving a task. They are distributed. They need to talk to each other and do something. Funny thing is that this protocol, because it was designed by Google, you can clearly see that they designed it for the enterprise because it has security built in, it has long-running tasks designed, it is built on standards that people can quickly adopt because we already have all the libraries to work against that. The interesting thing from my point of view is the modality agnostic side of things. I'm really used to deal with text, like when I use HTTP, for example, or binary. But dealing with video and audio and imagining two agents sending videos to each other, well, that's definitely going to introduce new use cases that I haven't done before. So I will just need to go and research a little bit more about that. Important about this, MCP and A2A complement each other. They do different things. You can actually use them together, as we will see in the demo. And finally, skills, which was something that Anthropic tried to define December 2025. So that's 6 months ago. It's very new. And it's just empty files, right? It's supposed to be a place where you put information so the agent know a little bit more about a specific topic. But something that worries me as a platform engineer is that thing there. So you have scripts, and scripts means shell files or binaries that the LLM can execute and do stuff. How do you manage that at the platform level? I've heard different people presenting about this. It's let's create skills and let's share it with developers. Sure. Yeah, let's share text files and scripts and do not version any of that. Good luck on managing that at some point. So yeah, it's getting complicated. I had this as one of the key takeaways of the sessions, but I decided to move it pretty early on. This is a post from a company that's called Arise. They have an entire platform to run and ship and evaluate and observe agents, right? And this is from a month ago, right? And basically the gist of the message, the post in LinkedIn is agents are becoming increasingly distributed. Well, what would you expect, right? And I think that this comes in a very specific context of a lot of agentic frameworks being designed to define agents in the same process, in the same application, and let them run in there, right? Not even as a separate thread. Some of them are multi-threading, but they just design multiple agents that they can collaborate if they are in process. But they realize, well, this is very difficult to scale. But also, these agents are going to be interacting with LLMs, with MCP servers. So at the end of the day, we just need to understand what is going on with these agents and what these agents are doing and which systems they are calling. So the end of the post says, the only way to understand the system is to propagate context across every boundary and correlate the work back to one trace, right? Again, we are very trained to deal with distributed systems. We have the observability tools to do trace propagation and to actually understand what's going on. So my point of view right now is how do we help all this ecosystem that it's growing to use the tools that we already have so we can actually get observability, traceability, and understand what our agents are doing at all time. I think that that's super important. And again, like depending on the framework that you looked into, some frameworks don't even have like observability in place, right? Like, or they have created their own way of observing agents, which will make it very difficult to operationalize like at the large enterprise level. So let me show you a demo that I created. In this case, again, I'm using LangChain in this case. So this is like a framework for creating agents that allows you to define agents inside your applications. So what I'm showing you here, like on the, what's that, right? I have the chat for ordering pizza to a pizza shop. And I have 4 different agents here, the store manager, the drinks agent, the cooking agent, and the delivery agent that are going to interact between each other to deliver a pizza order, right? The interesting thing about this is that behind the agents, we have like normal traditional services, like microservices, right? So we have a drink stock for fetching the drinks, an inventory with the ingredients, ovens, and bikes to actually cook the pizza and deliver the pizza to the customer when it's done. So if I order here, for example, can I have runny pizza and a beer? Right? You can see like the store manager agent here. I don't know if you can see that in the back, but the whole idea here is that the store manager will pick up the order. It will actually parse my request and try to understand if it actually can fulfill that order. In this case, it's checking the inventory and saying, yes, I can do that for you. Just confirm, and I will move the order forward to the other agents, right? So now you can see some sort of like agent orchestration where the drinks agent is going to fetch the drinks, and the cooking agent is fetching the ingredients to then go and reserve an oven to cook the pizza, right? And I thought how difficult it could be to build this kind of applications. I was completely wrong. Like, I thought this will be super easy, and actually there are a lot of nuances there that, for example, doing an MCP request here that actually blocks the LLM, so the LLM cannot do anything else until the MCP call ends. And that's like, if you use messaging or like an asynchronous approach, it will be much better. But the protocol is trying to support that now. You can see here the bike was reserved and then used to deliver the pizza order, and the order got delivered to the customer, right? And it becomes kind of like interesting of like asking this question of what happens, for example, if you run out of cheese, right? Or what happens if you have a lot of agents trying to reserve ovens to cook pizzas, how they are going to battle for the resources. And remember that each of these agents is possibly a different LLM that it's trying to resolve some queries based on the data that they have, right? Using LangChain in this way, it's very useful because like you are not using kind of like the Cloud Code binary that has a complete harness to do coding stuff, right? Like you use something that only have access to the tools that it needs to perform the task, and it has a system prompt that basically defines clearly what it needs to do. So let me show you a little bit about like the architecture of that. So you can think that you can create like actually some skills, and you can create some very large system prompts saying this is how you deal with the pizza order, right? And then you have an MCP server to connect to your APIs that are already existing in your organization, right? Like to use to automate that. But this kind of like miserably fails pretty quickly because agents, like LLMs in general, they have like a hard time to follow steps one by one and do like long orchestrations of things. So sometimes they forget steps, sometimes they find an issue and then divert and then not deliver the order, for example, or sometimes they just miss an ingredient and then just move forward. So the architecture doesn't look like that. It looks more like this, right? And again, this is just a distributed system. This diagram was created by by just prompting, like Claude to say, just try to describe the architecture. And it did a pretty good job of saying, well, you have 4 agents, like the store manager, the delivery agent, the cooking agent, and on purpose, I designed the drinks agents in memory there, right? So the idea here is to show that now you have different agents, they are different containers, and we are running all these agents inside the Kubernetes cluster in GKE, right? That's the repo, so if you want to run the same example in your kind cluster, you just download the repo, run a script, and you get the application up and running there. Interesting here is like, again, you start thinking about, okay, what happens if that container dies, right? Like if the cooking agent container dies. Well, it's Kubernetes, it's going to get restarted, but you need to make sure that you have the right mechanisms in place to continue processing the order like where you left off, right? Like if you were cooking a pizza and you reserve an oven, you need to be able to have like a way to just continue and then move forward. You can see here that for agents to communicate between each other, I'm using the A2A protocol by Google, right? And that is a thing, right? Like the same with MCP, right? Like when I want to interact with a tool, I'm using an MCP server that I created and I bootstrapped using a framework that already exists. But both A2A and MCP, they are two new protocols that I need to learn on how to observe. And they have, again, a lot of detail, like small details that become really, really painful. And your engineering team, like your platform team, will need to go through the experience of learning these protocols and figure out how to observe them correctly. You see that every agent has access to an LLM, and that, again, makes you wonder of how am I going to manage all the authorization tokens for all these LLMs, and how I'm going to rotate these tokens like every day or like every month. And finally, I'm showing you the use of skills on the delivery agent. That uses like a script file to interact with an API. That's the worst of the worst. Yeah, to show what people is doing, I want to see how difficult it is to see that like in action, and how do you observe, how do you understand when things go wrong in that space. So I have 9 more minutes, and I wanted to talk a little bit about something that I see the industry aligning on, right? Like we are talking about agentic engineering for designing these applications and what it means. And it's good when I see this kind of we are converging on the message, right? And some people define more levels, less levels, but I think that we are all going in the same direction, because understanding where your organization is today and where your organization should head tomorrow, and what are the steps that we need to take is super important. So for this super simple example, I try to create examples that match to the pizza store, right? Like level 1 would be something like you only have the chatbot that allows your store to parse whatever the customer is asking for, and then you give the human team the things that they need to do, the list of actions that they need to do. Level 2, it's more about, I think that it kind of makes sense to think about cloud code, that is generating code, but in this case, it would be more like the agents are actually defining what the cook needs to do. It's basically putting everything in place, but then the human is executing the actions, basically, or approving something, whatever the agent is helping. And the level spec-centric, it's a little bit more on that, how do we raise the level, right? Instead of approving every operation that the agent is executing in the real world, what we want to do is we want to do evaluations. We want to see what the customer asked in the first place and what it got delivered. Right? I think that's super important. And it's a very conceptual way of thinking. It's now we don't look into the individual actions that the agent will execute, but we look into the outputs. And then we have a way to score if that output is good enough or not. And that level basically allows us to go into the autonomy discussion. It's how do we build agents that are autonomous, right? And there is a bunch of blog posts about that, comparing self-driving cars to agents, right? The journey for us to build self-driving cars has been extremely long, but we have gone through these different levels where level 4, for example, is we have Teslas that will drive on their own, right? But you still need to be behind the wheels, right? So you just need to, you give autonomy, but to a certain point, right? And full autonomy will be more like a car where you just don't even have a steering wheel because it can drive on its own, right? Why would you need to intervene? But for full autonomy, humans are still needed, for example, to, if the oven breaks, well, somebody needs to fix it so the agents can keep cooking pizzas. And all of this is to say that, again, the industry is kind of trying to go into level 3, spec-driven development, but it's quite hard to get there because I don't think that we have all the tools that we need to do that. And the first step for me, I've seen a lot of presentations about observing agents, right? The first step is to collect data, right? We need to collect data about what these agents are doing. And I still believe that today this is pretty hard, right? Because we have new protocols, we have new kind of data, and then we have a new shape of observability that is popping up. So talking about that, I wanted to quickly show you the trace, in this case for a pizza order, right? So this is a trace that I executed before. You can see I wanted to show you quickly here, it has 238 spans. That's quite a lot of interactions, service interactions for dealing with a simple order. And believe me, it took me quite a while to get these frameworks and these MCP servers and the specific implementation of the A2A protocol to actually propagate trace context so I can see all these interactions together. So what you will see here is that agents are picking up stuff, the chat agent is picking up the conversation and then using a tool to process an order. And then you will see the in-memory drinks agent fetching the drinks. We can see here the interaction with the LLM. Let me see here if I can open this and zoom out. And this is kind of like where the industry is at this point, right? Like we have something called OpenTelemetry GenAI semantic conventions. There are a bunch of properties that we can add to our traces to actually see the prompts, for example, to start understanding the conversations that these agents are having between each other or internally, just to process and process the order, basically, and call different systems. But also, we can correlate that with the tool execution, right? So in this case, we can see that the agent was trying to acquire a drink, right? Like that's acquiring a drink. And for that, it interacted with MCP, where you will see these kind of like crazy post messages, right? Like that are a little bit cryptic. But at the end of the day, that's kind of like, okay, maybe we can just ignore that span. But you will see the jump to the MCP server, and then depending on the protocols that we are using to interact with our services, you will see the drink service responding in this case, right? For me, it's super important not only to see the traces, but also see how the logs of this execution correlate. So in this case, this little diamond here allows me to go to the logs views here, right? So you can see here, this is just a structural log that was captured when I fetch a beer, and it basically contains the item that I was fetching, but also the remaining quantity, right? So I can see while the agent was getting this resource and doing something useful for it. And down here, this is something where I think that we need to improve quite a lot, like observability is the A2A protocol. Depending on the library that you're using, it will look differently, but you will see here like a post send message, very cryptic as well, to the cooking agent, and then the cooking agent will pick it up, right? So everything that you see here, it's pretty much a different service that it's just receiving a request and dealing with the order. And we need to make sure that we make the whole interaction kind of like understandable for the user. Interesting enough, based only on data, we can construct the architecture that I showed you before that basically shows the store, it's not rendering well, the store management agent interacting with the cooking agent. That's my laptop resolution, yeah. So the cooking agent and interacting with the LLMs, right? Which is also important to understand, right? Like you don't want agents that will go straight to Anthropic. You will probably want agents that will go through a gateway that it's limiting kind of like or understanding the traffic that it's flowing through. So again, based on the same data, we can just actually look into the architecture of the application. But still, this, again, like this very simple demo that I've just created that is running on GKE, it's a distributed multi-agent system, super simple use case. It can fail in so many different ways that it becomes hard to observe, right? And as an industry, we are just building the tools to actually do this in an efficient way, but I think that there is still a long way to go. There are tons of things that we can build to make this easier. And it goes back to that question. It's like, do we really need to use agents for certain tasks? Can we just reduce the amount of LLMs that we use to do things that we can actually do with an API call? And I think that we will just iterate on that idea on defining the architecture and the limitations of these kind of systems. The system is very non-deterministic in the sense that every order that I process, it will have a different amount of spans inside the same trace. So it's very difficult to compare orders. You need to have something a little bit high level to compare. That's pretty much what I have in this slide. The demo, if you run it locally, instead of using -0 as I showed, it will use Jagger, so you can just see all the traces in Jagger. In Jagger, you cannot correlate the logs, so that's why I wanted to use that. But I think that the bottom line is that more telemetry is not the same as better telemetry. So monitoring things like MCP or A2A, we'll just need to build muscle as platform engineers to actually manage this at scale. Again, the non-determinism is hard, and it becomes part of kind of like the platform responsibility to deal with that non-determinism, right? Like we need to have the guardrails at the platform level to deal with that. And luckily for us, we have semantic conventions on top of OpenTelemetry, and I think that the industry is going there, but it's not still there, right? Like all the frameworks use different conventions or different versions of the same semantic convention, which is painful. So I'm really hoping that by the end of the year, or even like before, we see kind of like a more convergence on that space. The thing that I'm trying to show you here with semantic conventions is that if you only look at the properties that are being set by the traces related to GenAI, you can actually have the full story of what the agents were doing, right? And not for a single agent, but for the entire kind of like group of agents that were coordinating in a simple order. So as soon as you have the right data there, for example, the order ID and the customer ID, for example, you can actually see all the conversations between the agents and then troubleshoot and improve your prompts and all that stuff. As I mentioned before, skills are very, very tricky. If you're fetching skills from the internet, you will get just random stuff that you will need to instrument. And in order to make it work for this example, we are actually need to start hacking the scripts that are being used there. In this case, I'm showing here that in the span, we are including the path for the script that is basically calling the API service by using like curl or something like that. So we wanted to have an example to see how difficult it is, and I do see a lot of frameworks and conventions needed to solve this problem like in a holistic way, not case-by-case basis. So just to finish, because I have like 15 seconds left, I think that, again, we are trying to build muscle on how these applications are being built by application development teams. They want to run these things at scale. I don't think that we are quite ready yet. There are platforms that are being specialized in this. If we want to run this in Kubernetes, we can, but I think that we need to prepare our platform teams to understand that these agents will run in different runtimes, and in some way, as a platform team, we will need to manage all this complexity in a single place. Raising the abstraction level to evaluate inputs and outputs, I think that's the next step that I see a lot of people building tools around, but again, there is no definitive tool to do this at scale. So I keep looking to see if somebody comes up with something in the open source that we can start using, so we don't need to reinvent the wheel every time. And moving past spec-driven and like intent-based development, it's all about trust, and I haven't seen any presentation today covering this, which I think that it's extremely interesting, right? Like, how do we build a model where we can say, well, I really trust this agent, it can do well, right? In this case, the cooking agent has cooked 10,000 pizzas. It failed 1% of the time. So it's more like a business question. Can I refund my customers 100 pizzas if things go wrong, right? In exchange for my agent to just do stuff. I think that that's kind of like the question, the next questions that we're going to try to answer is like, how do we record data about agent execution and build a trust model that we can actually use to make decisions dynamically. So that, I think it's coming to our platform's services and capabilities at some point. So main key takeaways from this session is observing agentic applications is quite hard. Even if you see vendors pitching kind of like tools specialized on this, you need to very question yourself, how are you going to adopt these tools at the platform level? The open telemetry GenAI semantic conventions are definitely a good step forward, but I don't think that we are there yet. So there's a lot of work that needs to happen there. If not, you're going to start using a vendor and you will get locked into that vendor for all your agentic workloads, which is kind of like not good. And of course, we need more conventions, not only for tracking agents, but for tracking agent orchestration skills and all the other stuff that I mentioned before. And I think that, again, telemetry is not only critical to understand what our agents are doing, but I think it's the foundational thing that we need in order to start building trust models, right? We need to record what our agents are doing today, so tomorrow we can actually use that information to make our agents better. Today, when you run like an agent, it's an LLM that will return something different every day, but it's not learning because it doesn't have new information. And I think that we need to start creating all these knowledge bases to retrofit into our agents so they can use and be smarter tomorrow. If not, they will just keep being dumb forever, or depending on external providers to get better for our agents to perform better. So I think that that's what I have for you today. Thank you for joining this session. And if you have any questions, I will be around. Yeah. Thank you, folks.